Comment 1717 tells you to be on the lookout for a very, very classic situation in probability where they ask you about two distributions at once. So, for example, if 3 days in a row I check the road outside my house to see whether see how many cars go by in a minute, and I'm interested in quiet days, and let's say the definition of a quiet day is no cars in a minute. Well, finding the probability of no cars in a minute is a Poisson question. Let's say there's normally an average of 2, and I want to know the probability that the random variable comes out to be 0. Well, that's a Poisson question, which you look up in a perfectly straightforward way using the table. Let's say you get a probability of 0.32. I'm just making that up. It seems like a reasonably high chance of getting 0 if the average figure is normally only 2. But let's say I do that 3 days in a row. Well, what now happens is that I'm doing something repeatedly, and that's therefore the binomial. So I've got 3 repetitions of something that has a certain fixed probability of occurring. So if I say, what's the probability of getting 1 day that's quiet? Well, I'm now asking you, what's the probability that the random variable comes out to be, what's the probability that the random variable comes out to be 1? So you now use this. So use the formula. You could go or alternatively you could go to the 0.3 to column of the 3 box of your binomial tables if there is one. Look up the figure in the 1 row, look up the figure in the 0 row and subtract. But what I'm saying with comment 1717 is that these situations are very common, where the probability figure for the binomial does not come from just general knowledge, like what happens when you toss a coin. Rather, it comes from part A, where you had to use the Poisson or some other distribution to find out that probability. So because those happen a lot, I strongly recommend that you be on the lookout for them.